Howdy, AP Pre-Cal. Well, and actually, IB Math. This is Ms. Kosh. I wrote this for my AP Pre-Cal students and then realized that it would be lovely for IB as well. It's an extension, it's a challenge for AP Pre-Cal from the 2.1 and 2.2 unit. And I like these first two proofs because IB hits proofs pretty hard. So it's kind of a two birds, one stone sort of situation. Let me work, I may not do all of these practice problems, but I wanted to do a little bit of it. First of all, anytime they tell us to prove something, you can't just plug in a value and show that it's true for a particular situation. And so you have to prove it's true for all situations. So with both of these, when they say prove that it's arithmetic or prove that it's geometric, you are proving for every case. Okay, so if you think about it, what does it mean to be arithmetic? It means that between any two terms, you have the same common difference. So we could say that the term a sub n plus 1 minus this term a sub n would be equal to that common difference. So that's what we want to do. We want to take this formula. And yes, you might see, you're like, well, Ms. Kosh, it's linear. Obviously, it's arithmetic. But I'm not asking you to say what's obvious. I'm asking you to prove it mathematically. And that's hugely important. Well, for AP, I want you to understand this concept. For IB, I want you to practice proofs. And you both can handle it. It's great. Okay, so I can say, well, a sub n plus 1, let's subtract away the term that came right before it, which is the nth term. And so this would be equal to, well, the a sub n plus 1th term is 10 minus 3 times n plus 1. The a sub nth term, I did not give myself enough space, is 10 minus 3n. And then this gives me a 10, a negative 3n, a negative 3, now a negative 10, and a positive 3n. And so you'll notice the 10s cancel the 3n, the negative 3n plus 3n is 0, and I'm left with negative 3. Okay, and so what this shows me is that I wrote something like, since the difference between two consecutive terms is constant. I really ran out of space. Since the difference between two consecutive terms is constant, comma, we know the sequence is arithmetic. I ran out of space, but there you go. And that would be our proof. It's showing it for every particular scenario, any value that you pick, any term that you pick. My kids historically have gone to, I think it's called Karen Dilliard's, and it's a test prep program. And Karen Dilliard's would say, oh, well, just plug in numbers to do your multiple choice kind of stuff, which is fine if you're on that sort of, I would call that, so they would say like, oh, well, look, let's try a of 4 and a of 5. And we'll say a of 4, plug in 4, what do I get? Negative 2, plug in 5, that's negative 15. I have negative that. Oh, look, the common difference is negative 3, I'm done. No, I would write on there KD math, which is bad math. It's test-taking skills, which is fine if you're test-taking and it's multiple choice and nobody wants to see your proof. But if you're actually headed to do something mathematical, you got to learn how to do a proof. Okay, the next one, so we want to prove it's geometric. And to do that, you would have to say, well, the ratio of a term divided by the term right before it would always be constant. So pick a random term and then the term right before it. So if I pick the nth term, the one that comes right after that is the n plus 1. You could switch this around, but I was just like, if this is the nth term, right after it is the n plus 1th term, and right before it is the n minus 1th term. So I was picking these two, and I did the same thing over here. But okay, so then we have g sub n plus 1 divided by g sub n. Let's see what that gives us. That gives us 3 times 5 to the n plus 1 divided by 3 times 5 to the n. Let's rewrite this a tiny bit. 3 times 5 to the n times 5 to the 1 over 3 times 5 to the n. What canceled? Well, there's a 3 divided by 3 is 1. 5 to the n divided by 5 to the n is 1. And we're left with the ratio is positive 5. Okay, and now we could say something similar. We could say since not the difference, since we said the ratio between two consecutive terms is constant, it's got a constant proportion of change. Since that ratio is constant, the sequence must be geometric. I ran out of space, but use what I said. Okay, super. Let's look at, let's jump to number 4. I kind of like this one. The mean of the 6th term and the 9th term of an arithmetic sequence is 69. So the mean, so that would be g sub 6 plus g, or I said g and I wrote an a. I meant a anyway. A sub 6 plus a sub 9 over 2 would equal 69. And then we also know that the mean of the 9th term, g sub 9 plus g sub 13, divided by 2 is equal to 125. Well, we have a problem here in that we've got 1, 2, 3 variables, but only 2 equations. So somehow we need to rewrite this into 2 equations, 2 variables, so that we can solve a system. So what I might do is, well, the smallest term that we know or care about, or that we need, is a sub 6. So what we could do is we could say, well, a sub 9 would be equal to, where do I want to, I need more space. Okay, hang on. I could say that a sub 9 is equal to a sub 6 plus 3 times my common difference. And I can say a sub 13 is equal to a sub 6 plus 7 times my common difference. So now I've got a sub 6, and then I'd have a sub 6 and d, I'd have a sub 6 and d, and a sub 6 and d. And I could have 2 equations with 2 variables. So let's write, and then first let's get rid of these fractions. That's kind of annoying. Okay, so this becomes a sub 6 plus, now I'm going to rewrite a sub 9 as a sub 6. This is not the only way to do this problem. I just was trying to figure out, and then multiply that by 2, I get 138. And then this other one, a sub 9, we said is a sub 6 plus 3d. And we said that a sub 13 is a sub 6 plus 7d. Okay, and that's all going to equal double that because I don't want to deal with fractions. That equals 250. Okay, now I really need more space. And I have in this first equation, I have 2 a sub 6 plus 3d equals 138. I have 2 a sub 6 here plus 10d is equal to 250. And now I can solve my system. I see 2 a sub 6 and 2 a sub 6, so let's make this top one negative because the numbers were smaller across the board. This is gone. This gives me 7d, not 70, but 7d. I think I'm funny. It's questionable. Is equal to 112. Okay, so then when I divide by 7, that goes in there one time with, what, 42, 6, so 16. So my common difference is 16. What did they ask? They asked for the 6th, the 9th, the 13th. Okay, so the 6th term, oh, well, let's go find that. 2 a sub 6 plus 3 times the common, the numbers are a little annoying. That gives us, what is this? 30 plus 18, so 48. So I have 2 a sub 6 plus 48 equals 138. Subtract, that's 90 divided by 2, that's 45. So a sub 6 is equal to 45. A sub 9 is going to be equal to 45 plus 3 times the common difference of 16. That's 48 plus 45, that would be 93. And then my a sub 13, was that the other one I cared about? Yes. Was equal to my a sub 6 plus 7 times the common difference. Oh, you know what? I'm going to cheat. I can do the hard math. I just forget how to multiply. 7 times 16 is 112 plus 45 is equal to 157. A sub 13 is equal to 157. So here's part of the answer, this, this, and this. And then let's double check. So then a sub n would be equal to a sub 6 plus n minus 6 times d. A sub n, a sub 6 we said was 45. N minus 6, my common difference was 16. I see 16n minus, what is that? 6 times, that's 60 plus 30, so 96. 45 minus 96 is 49. Goodness gracious, you guys. 45 minus 6 times 16. That's negative 51. Did I know that? Was I? Anyway, never mind. Okay, here we go. We can verify and say, I can come in here to the table. I don't remember what I was doing last, but delete. Who knows what I was doing? 16x minus 51. And so I can look at my table and try, I wanted the 6th term, I wanted the 9th term, and I wanted the 13th term. Okay, 45, 93, and 157. That tells me I'm right. Okay, that's good. I also, let's do one more of these problems, and then you can try something else. Let's work with, I don't know, Let's do this when it has smaller numbers. Okay, the arithmetic sequence A sub n matches several terms with a geometric sequence G sub n. We are told that A sub 1 equals G sub 1 equals 6. So A sub 1 is equal to G sub 1 is equal to 6. A sub 4 is equal to G sub 2. Now keep in mind, I can either write G sub 2 in terms of G sub 1, or I can write A in terms of A sub 1, A sub 4 in terms of A sub 1, and I think that you should try both. So pause the video here, see what you can do. But I know that A sub 4 would be equal to A sub 1 plus 3 times the common difference, which actually the A sub 1 is 6, so this would be 6 plus 3D. And then they tell me what else? They tell me that A sub 10 is equal to G sub 3, which A sub 10 would be equal to A sub 1 plus 9 times the common difference. A sub 1 we said was 6, 6 plus 9D. Okay, so now we have each of these subsequent terms in this geometric sequence written in a way where we just have that one variable of D from the arithmetic sequence. So what do I know about geometric sequences? I know that G sub 2 divided by G sub 3 divided by G sub 2 would be equal to G sub 2 divided by G sub 1. Any subsequent terms like that would give me the same ratio. So let's take what we know. The third term of the geometric sequence is 6 plus 9D divided by the second term, and that would be equal to the second term divided by the first term. Now let's cross multiply. I'm going to get a D squared if I go, so I'll do that first. It doesn't really matter. 36, this is 18, double 18 is 36D, and then I see plus 9D squared is equal to 36 plus 54D. Okay, this is quadratic. I see 9D squared. Subtract 54, what is that? 54 minus, I lied. 36 minus 54, is that negative 18? The 36 is canceled. Now I'm not sure. Goodness gracious, you guys. I can do the hard stuff. 36 minus 54, it is negative 18. I was just not confident. I can factor out a 9D and I'm left with D minus 2. Okay, so this tells us that D equals 0 or D equals 2. But if I have a common difference of 0, then it's boring. I mean, it's just a sequence with every term being 6. Well, okay, then that means that the common ratio is 1, and that's boring. So I don't know if the definition of arithmetic allows us for a 0 constant, but I'm not going to do that. We're going to exclude that. Okay, so that tells me here that when I plug in 2, I have, okay, so my first term was 6. My next term, I have 2 times 3 is 6 plus 6 is 12. Here I have 18 plus 6 is 24. So notice 6, 12, 24, my common ratio for the geometric is 2. So I can say G sub n is equal to, I could say 6 times 2 to the n minus 1, or I could say that it's 3 times 2 to the n. If they don't give you a format for it, then you can pick either one. If it shows up in multiple choice, then you have to match theirs. If they tell you write it in the form whatever, then follow those directions. The arithmetic, I am out of space. The arithmetic would be A sub n is equal to A sub 1 plus n minus 1 times D. What do we know? We know that our first term was 6. We know n minus 1, our common difference was 2. Okay, and so my A sub n would equal to 2n minus 2, so plus 4. So let's double check. A sub 1, plug in 1, I get 2 plus 4 is 6. A sub 4, I have 8 plus 4 is 12. Yep, that's good. A sub 10, I have 20 plus 4 is 24. And so we're good. All right, I hope that was helpful. Go practice. Like, subscribe, comment, do all the things, and go practice.